This is Algebra 2, Unit 10, Lesson 1 on power functions. Before we start to analyze polynomials of degree higher than 2, which are quadratics, we will look at very simple functions known as power functions. So let's look at the formal definition. A power function is any function in the form of f of x equals ax raised to the b, where a and b are real numbers not equal to 0. So basically, a is a coefficient and b is an exponent. So, for each of the following power functions, state the value of a and b by writing the equation in the form y equals ax plus to the b. So y equals 3 over x squared. How could we get this so that the x is up next to the 3? Well, if we move the x up, that's going to give me y equals 3x, and it changes the exponent to negative. So this is 3x to the negative 2. So that means that a is 3 and b is negative 2. Okay, now for letter b, y equals 1 over 7x cubed. Okay, now for the x to move to the top, it has to become negative, but does the 7 have to go with it? No, the 7 stays where it is. The 7 can stay there because that can be part of the a. So this is 1/7 x to the negative third. So this is going to go up here. The 7 stays where it is. So that means your a value is going to be 1/7, and your b value is going to be negative 3. All right, y equals 8 times the square root of x. Well, how do we write the square root of x with an exponent? Well, remember, it's power over root, so this is actually y equals 8x to the 1/2 power. So ax to the b, a is going to be 8, b is going to be 1/2. All right, y equals 6 over the cube root of x. Well, first of all, let's write this with a fractional exponent. So this is equal to 6 over x to the power over root, this is going to be 1/3. Okay, so to get this to be written in ax to the b form, the x has to move up, so that'll be 6x to the negative 1/3. So a will be 6, b will be negative 1/3. All right, so that is looking at ax to the b and rewriting equations so that they are. Now, the characteristics of power functions depend on both the value of a and the value of b. Most important, though, is the exponent. The a is certainly a vertical stretch of the power function. We talked about stretching in the last unit. So let's look at the first characteristic of y equals ax to the b. What can be said about the y-intercept of any power function if b is greater than 0? Okay, so we just had a couple power functions. For example, we had y equals 3x to the negative 2. That was the first one and the previous one, 3x to the negative 2. All right, now what is the y-intercept of this function? Oh, for b is greater than 0. Sorry about that. Let's use 3x squared. Okay, for b is greater than 0. Okay, now for the power function, in a y-intercept, we know that the x is going to equal 0. So if I plug in y equals 3 times 0 squared, y is going to be 0. So that means the y-intercept is going to be 0. Is that going to be true for all power functions? All right, well, let's try one with a fractional exponent. We had 8x to the 1/2. 8x to the 1/2, the square root of x. Y is equal to 8 times 0 to the 1/2. Is going to be 8 times 0, which is still going to be 0. So the y-intercept, it will be equal 0. Y-intercept equals 0. When b is positive. Okay, so any power function will have a y-intercept of 0 when b is positive. Okay, now what if b is negative? B is less than 0. All right, so let's use 3x to the negative 2, for example. Okay, and the y-intercept is still going to be 0. All right, so this is y equals 3, remember this is 1 over x squared, 3 times 1 over 0 squared. Oh, can we do that? 1 over 0 squared is going to be 1 over 0, which is undefined. When you divide by 0, that is undefined. Okay, so this means you have no y-intercept when b is negative. So if you were to graph this, y equals 3x to the negative 2, there will be no y-intercept. It will never touch the it will never hit the y-axis. So when you have a negative exponent on a power function, it gives you a no y-intercept. All right, so for now we're going to concentrate on power function when the exponent is a positive whole number. So using your table, we're going to fill in the following values for common power functions. Okay, so I'm going to use my calculator. I'm going to use table ask on there. All right, so the first thing I'm going to do is I'm going to put in my power functions and y equals. All right, we have y equals x squared. We have y equals x to the third. We have y equals x to the fourth. And we have y equals x to the fifth. All right, now since I'm just going to look from the values from -3 to +3, I'm going to go to table ask. So I'm going to go to second, and the window key is table, and I'm going to change auto and independent down to ask. And I want to start it at well, it doesn't really matter. I'm going to go down to table ask down here. I'm going to change this to ask. All right, now remember when we go to table ask, what that does is it gives me a blank table. So what I'm going to do is I'm going to put in my x values. All right, so for my x value, my first x value is -3. Okay, so here is my values. I have when x is 3 for x squared, x cubed, x to the fourth, and that. So we have 9, -27, 81, and -243. So let me put those in. All right, so we had 9, -27, we have 81, and we have -243. All right, so let's try -2. Put in -2, 4, -8, 16, -32. All right, so 4, -8, 16, and -32. Okay, let's try -1. 1, -1, 1, -1. So we have 1, -1, 1, -1. All right, now 0, we shouldn't even have to put in the calculator. 0 is going to be 0 no matter what we do here. It's always going to be 0. Something squared, cubed, fourth, or fifth power will always be 0. And the same thing for 1. All right, 1 squared is 1, 1 cubed is 1, 1 to the fourth is 1, and 1 to the fifth is 1. Okay, let's do 2. X is 2. 4, 8, 16, 32. 4, 8, 16, 32. Okay, and one more. And let's do 3. We have 9, 27, 81, 243. Okay, now we should see a pattern happening here. 9, 27, 81, 243. Okay, let's look at the x squared function. When we're looking at the x squared function, we should see a pattern here. What do we have for x squared? When we had input of 3, we had output of 9. When we put an input of -3, we also have an output of 9. -2 is 4, +2 is 4. -1 is 1, 1 is 1. So that tells me that opposite inputs give you the same output. So what kind of function is x squared? Well, that's going to be an even function. That's the definition of even. Opposite outputs give you, or inputs, sorry, give you the same output. Opposite inputs give you the same output. All right, so that means that's even. Okay, so what other function is even? Opposite inputs give you the same outputs. Well, that would be x to the fourth. This one is going to be even as well. That's an even function. Okay, so look at x to the third and x to the fifth. When we have -1, we got -1. When we had +1, we got +1. When we had 2, we got 8. -2, we got -8. All right, so that means opposite inputs give you opposite outputs. So what does that tell you about this function? It is going to be odd. All right, so x to the third is an odd function, and x to the fifth is also odd. So we can notice that pattern when we're doing that. So just basically to remind us, we should note that the power function has an even exponent, then positive and negative inputs have the same value. When the power function has an odd inputs, positive and negative inputs have opposite outputs. This is the definition of even and odd, which we were just talking about. Okay, now, using the calculators, let's sketch the power functions using the standard viewing window. So if I go to my calculator here, I'm going to go to y equals. I'm going to shut the other ones off so I can see which one I'm talking about. So I'm just going to press enter and shut these off until I'm ready for them. All right, enter. Oh, I turned that one on. And I'm going to turn this one off. Okay, so let's graph y equals x squared on our graph. There's y equals x squared. So it's going to look like that. All right, so we could have probably predicted what that was going to look like because we've done a lot of parabolas. So there's y equals x squared. Oh, that's really bad. Let's see if I can draw that a little neater. All right, so it goes to 0, 0, and goes up like this. So that's y equals x squared. Okay, now let's do y equals x to the third. All right, so I'm going to shut this one off, and I'm going to turn this one on. Press enter. I'm going to graph that. Okay, so y equals x cubed looks like that. All right, so if I want to graph that, it's going to look something like that. Okay, so that is y equals x cubed. All right, and let's try y equals x to the fourth. All right, so we'll go down here and turn this one off and turn this one on. Y equals x to the fourth. What does that look like? Okay, it kind of looks like the x squared function, but it's a little flatter at the bottom. So let's graph that. It's going to look more flat at the bottom, going up like that. And then x to the fifth. All right, go down here, turn x to the fourth off, and then turn on x to the fifth. All right, and there's x to the fifth. All right, it kind of looks like the x to the third, but a little flatter in the middle. So if I go to my function here, see if I can draw it a little bit flatter in the middle. It goes kind of up like this, and then flattens out, and then goes up like that. Okay, so let's look at the pattern that we have here. Okay, look at x squared and x to the fourth. What do we notice about the end behavior? Well, remember these are both even functions. This is even and this is even. The end behavior. So the ends are in the same direction. So they both point up. Okay, so the ends in the same direction. And that makes sense because remember we said opposite inputs give us the same output. So they're going to point up like that. All right, now B and D are odd functions. This is odd and this is odd. From the last exercise we realized that. So what is the end behavior? The ends are going in opposite directions. So this one goes down while this one goes up. The ends are in opposite directions. So you can look at a function and tell if it's even or odd by its what's called its end behavior. It ends in opposite directions. And that will always be true. Okay, so even functions, the ends are in the same direction. They either point up or point down the same way. And the odds, one points up and one points down. All right, so which of the following power functions is shown in the graph below? Explain your choice. Do without the use of the calculator. All right, well, first of all, which way are the ends pointing? All right, they're pointing the same direction, which means that this is going to be an even function. So that eliminates number 4 and number 1. Okay, so it's either going to be 6x to the 8th or it's going to be negative 3x to the 10th. Well, if this is pointing down, so it points down, so that means that a is going to be, your leading coefficient is going to be negative. Is negative. So that means that it have to be number 2. Okay, so the end behavior of polynomials as the input variable gets very large, both positive and negative, is important to understand. We'll explore this in the next exercise in the next class.